This is a very important model of objective from the chapter nuclear chemistry, and this is related to one of the applications of radioactive isotopes, that is finding out the age of rock. Here the ratio of the lead and uranium is given as 0.25, and the half-life of this uranium is also given. We need to find out the age of the rock. We have the expression for calculating the age of rock as lambda equal to 2.303 by T into log 1 plus Pb206 upon uranium 238. And we also know that this lambda is equal to 0.693 by T half, and which is given as 4.5 into 10 power 9. And this is equal to 2.303 by T, that's what we are calculating, into log 1 plus 0.25. And why it is 0.25? Because it is given that the relative number of Pb206 and uranium-238 as equal to 0.25. So now it becomes log 1.25. It is nothing but equal to log of 5 by 4. So on rearranging and finally calculating, we get the answer as equal to 1.44 into 10 power 9 years. Let's see the detailed discussion how we got this particular expression for calculating the age of rock. You need to know one thing, that whenever a rock was initially formed, it contains huge deposits of uranium-238, and as this is radioactive in nature, in due course of time that undergo disintegration, and the final product formed is nothing but Pb206. So after some time, means after some years, now the rock has both uranium-238 deposits as well as Pb206. And you need to also understand here that the entire Pb206 formed here, it is only by the decay of this uranium-238. So from this particular data, we can easily find out the age of the rock. And it is like this. We know that radioactive decay follows the first order kinetics, and we have the expression as lambda equal to 2.303 by T into log N0 upon N. What is N here? It is amount of substance left after time T. So what is the number of moles of uranium-238 left after particular time T? And what is this N0? It is the initial number of moles of uranium-238. And for this one, as we don't know when the rock was formed and what is the initial quantity of uranium-238, we can get it from this particular number of moles. Why? Because this is the amount of uranium left after time T, and this is the amount of lead formed only from this uranium-238. So this total number of moles is nothing but equal to the number of moles of uranium originally present in that rock. So N0 becomes equal to number of moles of uranium-238 plus number of moles of Pb206. Then after substituting in this particular expression, we get lambda is equal to 2.303 by T into log uranium-238 moles plus Pb206 moles, which is nothing but N0, upon number of moles of uranium-238, which is nothing but N. And this becomes lambda is equal to 2.303 by T into log 1 plus Pb206 upon uranium-238. And once half-life is given, you know how to calculate lambda, which is 0.693 by half-life. And the relative number of Pb206 and U238 in this numerical is given as 0.25. And substitute those values and do the calculation. You'll be getting the final answer as equal to 1.44 in 10 power 9 years. So our answer is option B.